Now we are going to see what is meant by algorithm. Algorithm, it is a step-by-step procedure to solve a problem. Say for example, I've asked you to add two numbers and store it in a third variable. What you will be doing? Say for example, my first variable is a equals to 10. My second is b equals to 20. I've considered a third variable, then c equals to 30, then print it. Done? I've asked you to add two numbers and store it in the third variable. What you have done? I've considered a variable a and I've stored 10 in that, and I've considered a variable b and I've stored 20 in that. Then I've added both of them. I've added both of them. C equals to a plus b. After adding c equals to 30 and I've printed c, right? These are following a particular number of steps, okay? A sequence of steps. My first step is this, my second step is this, my third step is adding, my fourth step is storing them, and my fifth step is printing the output, okay? This is meant by algorithm. Generally, what does an algorithm do? It gives the instructions to the computer what to do and what not to do, okay? Say for example, let me come to the real life. Say for example, I have a printer, okay? That printer is connected with 3 or more systems. So at the same time, me and someone else tried to give the print. Who will be accessible to the printer first? Someone who did it first, right? Okay. Say for example, I have done it at the time 1. The second person did it at time 2. Who will be accessible for the printer? Me, right? Otherwise, so I've given you an instruction that the person who has less number of prints should be given that. So I have 100 prints to take and the other person has 10. Who will be given? This is my printer. Okay. I have given them. I want to print my data and I have sent my data to print at time t1. Second person also send the data to the printer at time t1, same time. Who will be given the priority? Okay, the CPU has to decide, right? So here what I'll be doing is, I'll follow different kinds of algorithm. My computer might follow any number of, I have a lot of algorithms. Say for example, there is an algorithm like FCFS, first come first serve. The person who comes first will be given the priority first. But in this case, two people has come at the same time. Okay, it's decided by my computer. Okay. So if my computer has allocated my CPU for, if the computer has allocated the printer for the person who has less number of prints. I have 10 prints and the other person has 100 prints. Who will be given priority? Shortest job first maybe. Okay. So this person might be given that opportunity, right? So this is meant by algorithm. So the algorithm is giving my computer the information who should be allocated with the CPU or who should be allocated with the printer first. This is meant by algorithm. So what are the characteristics of algorithm? We have 6 characteristics of algorithm. My first one is input. When you're trying to do any algorithm, when you're trying to do any task, you should have input. Inputs can be either 0 or more number of inputs. So the same example, addition of 2 numbers, I've took 2 inputs here. I have two inputs. So I might take any number of inputs. I might take 100 numbers and I will add them. Okay. So what am I doing? I can take any number of inputs. So my first characteristic property is 0 or more number of inputs. Okay. One is output. The task should be giving at least one output or more than one output. Okay. Say for example, you have considered addition of 2 numbers and storing it in the third variable or printing it in the third variable. First I've considered 2 numbers, then addition, then I've got some number, right? I got an output, right? My third one is definiteness. Each step should be clear and unambiguous. Algorithm should always be definite and each step should be clear and Unambiguous means no doubts. It should not create any kinds of doubts. Okay. This is called as definiteness. What is meant by finiteness? What is meant by finite? It should be countable. Okay. It should not run as a loop. You know, you will be watching time machine movies. One act will be performed. After that, it goes to the loop and the same act will be performed. It should not happen like that. Okay. After few number of steps, the program should stop. Say, consider you went to the ATM. Okay. What you will do? First, what action you will be doing? You will insert the card. After inserting card, you will select whether it is a current account, savings account, loan account or something. Say for example, you have selected the savings account, and what operation do you want to perform? You want to either deposit or withdraw or some display balance or something. So say for example, I've asked withdraw. It will be asking me amount, then PIN number. Then if everything is good and my amount is available, then then it will give me my amount. Then stop the program. Right? It won't go on continuously asking some or the other instructions. Once I get my amount, I will take out my card and leave. Right? This is called as finiteness. Must terminate after finite number of steps. Okay? Next one is effectiveness. It should be simple and executable. It should not contain large words and things that are not understood by the people. It should be very clear, simple and executable. It should be practically possible, not something like not possible and you can only explain the hypothesis of something. Okay. The next one is efficiency. Good algorithm should be fast and use less memory. Say for example, let me come to the real-time example. I want to go from location A to B. Okay. To go from A to B, if I take 30 kilometers and I have another option also. There is a location C. If I go to C from A, I will take 15 kilometers. And if I go to C to B, I'll take around 10 kilometers. Which one will I prefer? I will prefer this route, right? Because it takes less distance as well as less time. I won't be using more time for going from this place to this place. In case if I consider this path, I will need 30 kilometers. I need more time, right? This is called as efficiency. And this efficiency is measured in time complexities and space complexity in data structures. You will be learning these two concepts in future lectures. Okay. So, this is meant by efficiency. A good algorithm should be fast and use less memory. It should not be consuming more memory, more cost, or like for example, it should be it should be executable in finite number of steps. It should not go continuing like a loop. So, these are the characteristics properties of algorithms. I hope you all have understood all these characteristics of algorithm. If you like my lectures, like, share and subscribe to Code with Laya. Thank you.